Hello, welcome to Quantitative Data Analysis. There are plenty of textbooks available out there to discuss and interpret data. So I'm going to give you the very basic information, but I would recommend that you review the likes of Bryman and Bell's textbook or Collis and Hussey's textbook on data analysis. So as an introduction, you need to think about data analysis as an early stage in the research process. You need to consider methods and the sample size, as they can actually affect the kind of analysis you can do. What are the types of variables that you can actually use in your data analysis that will then give you some information that you can write about? Well, the types of variables are interval, ordinal, nominal, and dichotomous. And these are the four types of variables used in quantitative data. In the next slide, I've actually given you some illustrations of each of these four types. So what is let's say, an interval data? As you can see here in the clock example, we actually have equal intervals between the time. So between 0 and 10, it's 10. Between 10 and 20, it's 10 again. So they are equal intervals. The next one is an example of a weighing machine and also checking people's height. This device provides two examples of ratio scales of height to weight. And then we have examples of questions of nominal scales and ordinal scales. Nominal, in a sense, is yes or no, or male and female. And you're choosing one of those answers between male and female. And then we have ordinal scales, which are scales of equal distance between each other. So very unhappy, unhappy, okay, happy, and very happy. That's actually a Likert scale of a 5-point scale. So how do we know how to actually formulate our question or to choose which variable to use? Diagrammatically, I believe that this diagram will help you in making those decisions. So are there more than two categories? If no, that is basically a dichotomous question, a yes-no question. If there are more than two categories, we have to question, well, can they be ranked in ordinal scales? If yes, we need to question about the distances between the categories and are they equal? If we can't actually rank the questions, then the variable is nominal or categorical. Concerning the distances between the categories, if they are not equal, the variable is ordinal, and if they are equal, the variable is interval or ratio scale. So there's a series of questions you need to think about when you're actually deciding on the variable. So when we're actually looking at one variable at a time, let's say, for example, gender, we would use the likes of frequency tables. So we're looking at the number of people or cases in each particular category. So we're looking at the number of people who are male and then the number of people who are female. That's frequency tables, typically expressed as a percentage of the overall sample. And interval or ratio data need to be grouped in order to present them in a frequency table. What diagrams can we use to show a univariate analysis? That is just one variable at a time. We might use a bar chart, a pie chart for nominal or ordinal variables, or where there's a varied list of variables such as an interval or ratio data, we would use a histogram, because there would be 5 or 7 or 9 variables that we're looking at under each category. So what might this look like? This is an example of a bar chart, and there we can see that it's a range of scales to choose from. And then we have a pie chart. And the pie chart is also showing maybe their reasons for visiting the gym. And again, a visual of the results actually helps the reader to understand what is being communicated. Then we have a histogram. A histogram presenting the bars closer together, showing the variances amongst the different age categories. In statistics, you have the measures of central tendency, and we have what's known as the mean, median, and mode. The mode is the most frequently occurring value. The median is the middle point within the entire range of the values. And the mean is the sum of all values in the distribution, then divided by the total number of values. In statistics, the mean would be the most common tendency to use a measurement to be used in stats. Then we have what's known as the measures of dispersion. Dispersion means the amount of variation in a sample. The measures of dispersion compares the levels of variation in the different samples to see is there more variability in a sample, in a variable in one sample than in a number. The range is the difference between the minimum and the maximum values in a sample, and then the standard deviation is the average amount of variation around the mean, reducing the impact of extreme values, those being the outliers. A bivariate analysis is where you're analysing two variables at one time, and maybe this is looking at the relationship between two variables, and you're searching for covariance and correlations between those variables. You can't actually establish the causality relationship between those variables. However, you can sometimes infer the direction of a causal relationship, such as if one variable is obviously independent of the other. And we could use contingency tables, which connects the frequencies of those two variables, and thus it helps to identify the patterns of association that have emerged between those two variables. What statistical analysis could we actually conduct here? And that would be possibly Pearson's OR, which is showing the relationship between two interval or ratio variables. The coefficient is showing the strength and direction of the relationship. It could lie between -1, which is showing a perfectly negative relationship, and +1, which is showing a perfect positive relationship. And we would use the bell curve to actually show us this relationship. The relationship must be linear for the method to work, so ensure that you do a scatter diagram first and ensuring that there aren't any outliers. The coefficient of determination is founded by squaring the value of OR, and this shows how much of the variance in one variable is due to the other variable. In today's statistical packages, all of these would actually be done for you. You just choose which one to do. So you need to ensure that you know that you are comparing two interval variables against each other. So analysing the relationship between two or mixed type of variables. So Spearman's row for the relationship between two ordinal variables, or one ordinal and one interval or ratio variable. The phi coefficient for the relationship between two dichotomous variables. Kramer's V for the relationship between two nominal variables, or one nominal and one ordinal. And where we're comparing the means when a nominal variable is identified as the independent variable, the means of the interval ratio variable are compared for each subgroup of the nominal variable. So knowing when to use these forms of statistical analysis, you need to understand what are your variables. So going back to ordinal, the interpretation of ordinal, nominal, interval and ratio, that is quite important for you. So when we're actually looking at 3 or more variables, the relationship between 2 variables might be spurious, and each variable could be related to a separate or third variable. A third variable might be moderating the relationship. It could be, for example, the correlation between age and exercise could be moderated by gender. So what are examples of spurious variables? Well, for example, it could be leadership style, could be dependent on the employee satisfaction, which is then employee commitment, which is then dependent on job satisfaction. So the statistical significance, how confident can we be that the finding from a sample can be generalized to the population as a whole? How risky is it to make this inference? And it only applies to probability samples. So how do we test for statistical significance? Well, we set up a null hypothesis. We may suggest there's no relationship between examined variables in the population from which the sample was drawn. We then decide on an acceptable level of statistical significance, 95% or 99% statistical significance, for example. Then we use a statistical test, and if acceptable level obtained, we reject the null hypothesis. If not attained, we accept it. But might we be wrong in choosing to accept or reject the null hypothesis? We may actually have errors, and we also have to be aware of different types of errors that might be there. And there's known as type 1 or type 2 errors, as this image identifies. What, though, are the tests of significance that we might actually use? And one which is commonly used in statistical analysis is the chi-square test. And this is used to explain the confidence that we have that there is actually a relationship between 2 variables in the population. The correlation of statistical significance provides information about the likelihood that the coefficient will be found in the population from which the sample was taken. And then we might be doing comparing the means or statistical significance, and this is using the F statistic. And this is expressing the amount of explained variance in relation to the amount of error variance. So let's go back to having a look at the chi-squared, and then we'll look at the correlation of significance. So the chi-squared, shown as an x with a squared, or 2, is applied to contingency tables. It establishes how confident we can be that there is a relationship between the 2 variables. The test calculates for each cell in the table an expected frequency or value, one that would occur on the basis of chance alone. But what's just important is that those cells have to be greater than 5. The chi-square value is determined by calculating the differences between the actual and expected values for each cell and then summing those differences. Don't worry, SPSS will conduct a chi-squared for you. You don't have to get out the paper and pen. Whether a chi-squared value achieves statistical significance depends not just on its magnitude, but also on the number of categories of the 2 variables being analysed. This latter issue is governed by what is known as the degrees of freedom within the table. And finally, correlation and significance. How confident can we be about a relationship between 2 variables? Whether a correlation coefficient is statistically significant depends on the size of the coefficient and the size of the sample. For example, if the coefficient is 0.62 and p is less than 0.05, we can reject the null hypothesis. I hope this video on quantitative data analysis, or more on the introduction of quantitative data analysis, was of some use to you. Thank you.